Okay, I thought since there's several of us that did not do so well on the Chapter 2 test, I would go back through the review, explaining each section and explaining how to do them again, just to make sure if you're interested in doing a retake, this would be a very good place to go through. So on the first section, it says describe the transformation of f of x equals x squared, identify the vertex, and sketch the graph. Okay, well, we know that x squared is a parabola, and if we look at what we have here, we have a x minus 7 and a plus 1 on the outside. That minus 7 on the inside tells me that I am going to the right 7, and the 1 on the outside tells me I am going up 1. Lots of kids got a little bit confused here because they saw the minus 7 on the inside and they thought that minus 7 meant left. Well, remember the formula is x minus h squared, and that's looking at h. In this case, h is 7, which means it's a positive 7, so it's actually going to the right. And on this section of the review, all we are having to do is identify the vertex. In this case, if we move to the right 7 and up 1, our vertex is going to be at 7, 1. So we can go over 7, 1, 2, 3, 4, 5, 6, 7, up 1. And for this part, we can just do a general sketch of the graph. We don't have to find points on each side. It just says to sketch the graph. On the other one, it has x plus 4 squared. That plus 4 on the inside tells me that I go left 4. And that minus 3 on the outside tells me I go down 3. Okay, which means I'm going to put that actually in the description of the transformation here. I'm going to go left 4, down 3, and my vertex is going to be at negative 1, 2, 3, 4, 1, 2, 3, right here. And I'm just going to sketch the general shape of my graph, and my vertex is at negative 4, negative 3. Again, going back up and looking at why we go to the left 4, our formula is x minus h squared, which x plus 4 is essentially like x minus negative 4 squared, which means our h is negative 4, which is moving to the left. Okay, on this section, we're still in vertex form, but now we're going to get a little bit more specific with our graph, and we are actually going to need to be a little more exact with our points that we have. So the first thing that I can do, well, always read the directions. So I need to graph my vertex, my axis of symmetry, and 2 values of x, 1 on each side of the axis of symmetry. So I can look at my equation, and I know that my vertex is at 1, 3. Positive 1, positive 3 is where my vertex is at. Positive 1, 3. Some other things that I know is that this negative right here tells me that I am going to be reflected, and this 2 is going to actually have an impact on my graph as well. So as I look, I have my vertex labeled, and my axis of symmetry is just the vertical line that goes through my vertex, like that. So now I need to pick a point on each side. Okay, well, I'm going to be a unit or 2 away from that. So I'm going to pick, see, I'm at x is 1. I'm going to use x equals 3. Okay, if x equals 3, I plug that into my equation. Maybe not. Which means I would have negative 2 times, oops, I didn't want x, I wanted to actually plug in 3 minus 1 squared plus 3. Again, the reason I chose x equals 3 is because currently my axis of symmetry is at x equals 1, and I want to be a unit or 2 away from that. And I want to pick a positive number, so I picked x equals 3. So I'd be at negative 2, 3 minus 2 is 2 squared plus 3. Negative 2 times 4 plus 3 is negative 8 plus 3, which is negative 5. So I know I have a point at 3, negative 5 on my graph. So I'm going to go ahead and label that 1, 2, 3, 1, 2, 3, 4, 5. Here I am. And then I can just reflect that across the other side, and now I have points on each side of my axis of symmetry, and I have my vertex, and then I can sketch my graph from there. Okay, looking at my next one, I have a fourth out in front. I have x minus 2 squared plus 1. Okay, so first things first, my vertex is at 2, 1. So I'm going to go over 2 and up 1. And then I know my axis of symmetry goes right through there. So I have my axis of symmetry labeled. Now I just need to pick a point on each side. Well, I'm going to use a nice easy number. I'm going to use when x equals 0. I could also have used when x equals 4. That would be a good one, because with this 1/4 out in front, I want to make sure when I put my x value in and square it, it's divisible by 4. So I'm going to actually go ahead and use x equals 4 instead. So I'm going to have 1/4 times 4 minus 2 squared plus 1. 4 minus 2 squared is 2 squared, which is 4. 1/4 of 4 is 1. 1 plus 1 is 2. So I would be at 4, 2. So I'm going to be at 4, 2, and then I can reflect that across. And if I would have put 0 in for x, I would have ended up at 0, 2. And then I can sketch my graph like so. Okay, then we have a little story problem. We have a ball is tossed in the air. The height and feet of the ball above the ground is modeled by the equation that's given there, where t is time in seconds since the ball was tossed. What is the ball's maximum height? So we're thinking about that on a graph, right? This is going to be the height. This is going to be time. So your x-axis is going to be time. Your y-axis is going to be the height. And if we think about what happens with a ball when we toss it, it goes like this and then it falls back down. Our maximum height is going to be at the vertex of that. Well, the vertex we have to actually calculate out, and it is in standard form. So if you notice, negative 5t squared plus 10t plus 3, that is standard form. Anytime we have something in standard form, that means in order to find the vertex, we have to find the axis of symmetry, which is the opposite of b over 2a. And then plug that x value into our equation to figure out our height, or our y value. So I'm going to have the opposite of b. So b is 10, so I'm going to have negative 10 over 2, and a is negative 5. So 10 divided by, or excuse me, negative 10 divided by negative 10 is just 1. So I know at 1 second, because my x value is my time, at 1 second I'm going to reach my maximum height. Then I just need to plug in 1 into my equation to figure out what that actual height is. So I'm going to have, I'm just going to plug that in, h of t, oops, I switched colors there, equals negative 5 times 1 plus 10 times 1 plus 3. So I'd have negative 5 plus 10 plus 3, and I get 8 feet. So my maximum height is 8 feet after 1 second. Okay, so now we look here, and this is an area where some of us were a little bit confused, and we are in standard form. So once again, in standard form, we're going to have to use our axis of symmetry, which is the opposite of b over 2a, in order to find our vertex. Okay, actually our axis of symmetry right here is going to be x equals the opposite of b over 2a, and then we take that x value, plug it in to our y, or plug it into our equation to get the y value of our vertex. So if we look at our first one, the opposite of b over 2a is going to be negative 8 over 2 times 2. Negative 8 divided by 4 is negative 2. So my axis of symmetry is at x equals 2 or negative 2. Oh, so it's our a value is negative 2. So we'd have negative 8 divided by negative 4 is positive 2. Let me fix that there real quick, maybe. So my axis of symmetry is at x equals 2. All right, so if x equals 2, I'm just going to plug that into my equation. So I know my x value of my vertex is 2. I'm going to come up here and plug that into my equation. So I'd have negative 2 times 2 squared plus 8 times 2 plus 7. So 2 squared is 4. 4 times negative 2 is negative 8 plus 16 plus 7, which gets us 15. So my vertex is at 2, 15. So I'm going to go ahead and plot that. And if you notice, my graph only goes to 10. So I'm going to be at 2. And then my 15 is actually going to be up here just a little bit. Sometimes that happens when I make an equation. All right, so I then need to actually finish off my graph. And I know in standard form like this that my y-intercept, which is when x equals 0, is just my constant. So in this case, it's going to be 0, 7. So this value came from my 7 right there. So I know that my y-intercept is going to be at 0, 1, 2, 3, 4, 5, 6, 7. And if I reflect that across my axis of symmetry, I'm going to have another point over here. So I'm going to have a graph that looks like this. It is reflected, so it is opening downward. And I can use that graph, and again, I'm going to use my vertex values to find most of the rest of this information. Okay, so my maximum value, or my minimum, in this case it is a maximum because it's opening down, so it has a high point. My maximum is at the y value, so my maximum is going to be at y equals 15. My domain, as long as there's arrows on the end of both of my graphs, is always all real numbers. My range is basically how tall it is, and if you look, my graph is everything that is below 15, because that's the highest point that it is. My maximum point is 15. My range is everything that is below 15, which would be y is less than or equal to 15. Then when we think about increasing and decreasing, I read the graph from left to right, and I am increasing up to this point, and then I turn around and I start to decrease on the other side. And increasing and decreasing is reading the graph left to right, which means I'm looking at the x value of my vertex. So I'm increasing, if you'll notice, to the left of that value. So I'm increasing to the left of x equals 2, and I am decreasing then to the right of x equals 2. Okay, and we can do the exact same idea here with the other problem on question number 2. Okay, now let's go ahead and look at the second question. It is also in standard form, x squared minus 4x plus 1. And a couple things that we notice about this equation is that the value of a is equal to 1, which means it's not going to be stretched or shrank or anything like that, and it is not negative, so it's going to open upward. Again, our axis of symmetry, we need to use x equals the opposite of b over 2a. Okay, which means if we are looking at our equation here, b is negative 4, which means the opposite of b is going to be 4 over 2a, which is 1. 4 divided by 2 is 2. So our axis of symmetry is at x equals 2. So I go ahead and I can sketch my axis of symmetry on my graph. My vertex is when I put 2 into my equation and figure out where my y value is. So I'm going to go back up to my original equation and substitute in x equals 2. So I would have 2 squared minus 4 times 2 plus 1. 4 minus 8 plus 1 is negative 3. So my vertex is at 2, negative 3. And I can also use my y-intercept. That's going to be my value when x equals 0. And it is also just the value of c. So my y-intercept is at 0, 1. So I zoom in here, 0, 1. And if I reflect that across, I'm here. And I can sketch my graph like that. And as I'm just analyzing my graph, my vertex here is at 2, negative 3. I am decreasing over here, and I am increasing on this side. Because again, that's because as I read my graph from left to right, I start here, I'm going down, 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 decreasing on this side, and after I hit my vertex, I am increasing on this side. So let's go ahead back down to the bottom here and analyze that graph. My minimum or maximum, it is a minimum because that has a lowest point, and it is at the lowest point when y equals negative 3. My domain, again, is always all real numbers as long as there's arrows on both ends of the parabola. My range relates to my y value, and in my y value is negative 3 at my vertex, and the graph opens up, so it is everything above or greater than y equals negative 3. And increasing and decreasing, we have that labeled up on our graph up there. It is decreasing to the left of x equals 2, and it is increasing to the right of x equals 2. So these take some time, they take some thinking about what's actually happening on the graph, but just keeping in mind that anytime you're doing these and you're evaluating our numbers, we are relating things back. Once we know our vertex, everything goes back to the x and y value of our vertex. So for instance, our x value is 2. When we are looking at our increasing and decreasing, it's related to x equals 2. And our y value is negative 3, and that deals with our minimum or maximum and our range. All right, here on the last page, you had to write an equation in vertex form, and the vertex form is given to you right up here, so you didn't even have to have that memorized. And what you do need to make sure that you do is you label the x, y, h, and k of the information that's given. So if it passes through point 13.8, that means that's your x and your y. Your vertex is at h and k. Then I'm just going to take that equation, or excuse me, that formula for vertex form up there, and I'm going to plug in all of my values. So I know y equals, so that's going to be y is 8. The only value I don't know is a, times x minus h. X is 13, h is 3, don't forget to square that, plus k, and k is 2. Now I'm just solving this equation for a, because that's the only value I don't know. So I need to do inside my parentheses first. 13 minus 3 is 10, squared, plus 2. Order of operations says we need to square that first. 10 squared is 100. A plus 2. If we subtract 2, we get 6 equals 100A. If we divide out 100, we get that A equals 6 over 100 or 3 over 50. Either of those are equivalent and would work. That's not our final answer yet, though. Our final answer has to be in vertex form. So our vertex form is always going to be y equals. We know the value for A is 3 over 50. And our parentheses is x minus h. Well, h is 3 squared plus k, which is 2. keeping in mind that we will have a y and an x in our final equation, and we have numbers for a, h, and k. So the second one is the exact same idea. We just need to label and substitute in. Passes through x, x and y, and here's h and k. So I'm going to have negative 15 is y equals a times x, which is negative 7, minus h, which is negative 5, squared, plus k, which is 9. Negative 15, negative 7 minus negative 5, that's the same as negative 7 plus 5, which would be negative 2. Negative 2 squared is 4, so we'd have 4a plus 9. If I subtract 9 from both sides, I get negative 24 equals 4a, and a equals negative 6. Again, that's not our final answer because our final answer has to be in vertex form. So I would have y equals, we figured out what a is, x minus h, so it's x minus negative 5, which is x plus 5, squared, plus k, which is 9. I had lots of kids that just substituted everything in and didn't actually evaluate the numbers and write it correctly in vertex form. So go back and re-listen or double check if you're confused on how to do these. All right, now we're going to use the quadratic regression calculator or feature on our calculator. So the first thing that you need to do is obviously make sure your y equals is cleared, your L1, L2 is all cleared out, and all that good stuff before we ever start, and that your stat plot is turned on. Remember, stat plot to turn it on is second y equals, and make sure that your stat plot is turned on. We had turned them off when we did graphing on our calculators for quadratics later after we did this. So make sure your stat plot is turned back on. So the first thing you want to do is you want to hit stat, and you're going to edit, and you're going to enter these values into your L1 and L2. You're going to put in your data in there. And then once you have all of those numbers in there, you're going to hit graph. If your graph does not show up, you can always hit zoom stat, which is zoom 9, and it'll zoom in on where your data actually is. And then once you have your data plotted in a scatter plot, you're actually going to calculate your linear regression to write, or excuse me, your quadratic regression to write your equation. So you need to do need to hit stat, and instead of edit where you went to enter your values, you're going to arrow over to calculate. So you're going to hit stat, calculate, and you want quadratic regression this time. Make sure you're on quadratic, not linear, because several kids accidentally wrote a linear equation instead. So hit, I believe that is 5, so you're going to hit quadratic regression, and you need to make sure that you have all of your L1, L2, and you enter down and you hit calculate, and it should bring up a value for A, a value for B, and a value for C. Whatever those values happen to be, in this case, A, if you round to the nearest 10th, or we shouldn't have to round on this one, I guess, do we? A, it looks like, is negative 16, B is 0, and C is 280. Which means when you're going to write your equation up here, it's going to be f of x equals negative 16x squared plus 0x plus 280. You don't technically have to put that plus 0x in there, but if it helps you with the place fillers, that's fine. Go ahead and put it in there. And then you go into the y equals. You're going to put in y equals negative 16x squared plus 0x plus 280. Hit enter, and then when you graph it, it should put a line going right through your data in your original graph. And then it asks you, once you have the equation written, use that equation to predict the height at 2 seconds. So that's when x equals 2. So that's when you're going to hit second trace, and it'll bring up across the bottom x equals. You're going to put x equals 2, hit enter, and it should tell you that at 2 seconds you are at 216 feet.